Okay, yeah, that sounds good. So now we can begin today's lesson. So, okay. So today we will be learning about chemical reactions, and science instruments and filtration. So yeah, let's get started. But let's start with a bit of a review from last week. So last week we learned about atoms, ions, and electron shells, right? Let's quickly review these concepts. So remember that what an atom was. So an atom is a basic building block of matter that cannot be divided into smaller parts using any chemical means. And we learned that the atom is made up of protons, neutrons, and electrons, right? We still remember what an atom looks like and what an atom is made out of. And electrons orbit the nucleus. And we learned about molecules, right? We learned about elements versus compounds. So we have nitrogen gas, N2, which consists of two nitrogen atoms. So this will be um, just one type of atom, right? Just nitrogen, but it can combine to form a molecule that has different kinds of atoms, like water. Water is H2O, so it consists of one oxygen atom and two hydrogen atoms. So this is an example of a compound where it has more than one type of atom. Okay. Yeah, we learned about, again, an atom last time. Remember that because the number of protons equals the number of electrons, the atom is neutral. And then we learned the periodic table, right? And then how we can read from the periodic table. And for example, we had a carbon atom, and over at the top, that is the atomic number, 6. That tells you the number of protons and the number of electrons. We have the chemical symbol in the middle and the atomic mass at the bottom. The atomic mass is almost equal to the number of nucleons, meaning the number of protons plus neutrons. And because electrons are very, very small, their masses are negligible, meaning they basically have no mass. So atomic mass is essentially equal to, yeah, the number of protons on plus the number of neutrons, right? That's how you can get the number of neutrons from the atomic mass. Remember, atomic number is equal to proton number, which is equal to electron number. Yeah, the atomic mass tells you the number of protons plus the number of neutrons. And then we learned about the types of elements. We know that there are metals, nonmetals, and semimetals. And elements are listed in the periodic table by their atomic number and whether they are metal, nonmetal, or semimetal depends on their position in the periodic table. We can see that the metals are on the left side of the periodic table, except hydrogen, which is a nonmetal. But nonmetals are usually on the right side of the periodic table. And then in the middle of the metals and the nonmetals, there are metalloids, which are between over here. Yeah. And then we learned about ions, right? Do you still remember about ions? Yeah, ions form when an electron is given or taken by another atom. So when an atom loses an electron, that formed ion was called cation. Remember? Yeah. And when an atom gains an electron, the ion is called an anion. So these are the differences. Loss of electron usually has a plus symbol. Right? It has a plus symbol because you are losing electrons, right? You are losing minuses. So your atom becomes positive, right? Because your your atom only has protons and no less electrons. That's why the atom becomes positive. But if you gain an electron, the atom becomes negative, right? Because there are more electrons, meaning it has more negative charges. Yeah, and we learned about how ions form, right? How do these ions form? Well, it forms by making a stable valence shell. Right? So in order to form a stable electron shell, it needs to form the structure. You remember the electron shell structure of two, yeah, eight or further, or two, eight. These are very stable, or even two, or even two. Those are very stable forms of electron shells. So an atom, like sodium atom, has 11 electrons, right? Has 11 electrons in total. Has 11 electrons. Sodium ion in total has 11 electrons. And I know that from the periodic table. Sodium has an atomic number of 11. So sodium should have 11 electrons. Yeah, let's fill in the gap with the shells. Right? So we can fill in the first shell that has two. Okay. We can fill in the second shell that has eight electrons orbiting. Okay, so we used 2 plus 8. So we used up to 10 electrons. But we have an extra electron here on the valence shell. This is the valence shell, meaning the outermost shell. Valence shell. The valence shell. Hmm? The outermost shell has one electron orbiting. But this is not stable, right? The sodium would want to get rid of this electron, extra electron. So a sodium ion would form by losing one valence electron. Yeah, right. And what is an ion that loses an electron? It is a cation ion, and it becomes positive. The charge becomes positive by forming a cation ion. Yeah, again, this is all a review from last week, but if you don't understand any of this, yeah, feel free to ask questions. Yeah. Yeah, if you have anything that you didn't understand, yeah, please ask. Okay. Yeah. Does everyone understand how ions form? Yes. Okay. Great job. Yeah, let's move on to one more example. Okay. Let's look at chlorine, Cl. If you have a periodic table in front of you, what is the atomic number of chlorine? Anyone know? Did you say 18?
18, yes.
Yeah, let's check. Um, okay, chlorine, so Cl, Cl. Oh, I think I see Cl over here.
17.
Oh, yes, that's right.
It's 17.
Yeah, that's right. It's 17. Yeah, great job. So chlorine, okay, has 17 as atomic number, right? 17. Yeah. That means it has 17 protons and electrons. Chlorine has 17 electrons. Okay, let's fill in our electron shells from 17. Okay, we fill in the first shell with 2 electrons. Okay, we fill in the second shell with 8 electrons. So that gives you 10. But the last shell has 7. 7. So it forms a 2, 8, 7 structure. So chlorine is 287. So it wants to make a 288 structure. So it gains 1 electron to form an ion. It's called chloride anion, right? Because you're gaining an electron. It is an anion. And it has a negative charge. Okay. Let's move on to the next one since I think everyone is understanding really well. So again, this is an electron shell concept. First shell has 2, second shell has 8, third shell can hold up to 8 electrons and more. And atoms try to have the electrons on their outer shell like noble gases. Noble gases are stable atoms. They are basically stable atoms. Okay. Yeah, we already looked at um, some of these ions as an example. So, one quick way to tell what an ion forms, right, without drawing it, is knowing that since sodium is over here, it just needs to lose one electron to become neon, right? To have the same electron number as neon. That's how you know which atoms form which ion. You can look at calcium too. This is 1, 2 away from being a noble gas. That's why it loses 2 electrons. Same with chlorine. It just needs one more electron to become an argon, right? Have the same electrons. With sulfur, you need two more electrons to become argon. And we can notice a pattern, right? Metals tend to lose electrons, right? Metals over here tend to lose electrons, and nonmetals tend to gain electrons. That's their properties. All right, great. Let's move on to today's lesson then. Yeah. So we said we will be learning about chemical reactions, right? So there are a lot of reactions that can happen in our lives between chemicals. Some examples are combustion, which is a burning a substance with fire. There's rusting. There's digestion happening in our body. There's photosynthesis, where plants use sunlight and water and carbon dioxide to make sugar. Batteries also use chemical reactions. There are also fermentation, washing, and baking. So let's watch this video, and this tells you about photosynthesis as a chemical reaction. Yeah, so we looked at this video and it talked about photosynthesis specifically, right? And how that is an example of a chemical reaction that we have. But remember that there are all these other types of chemical reactions that can happen. Things like combustion, rusting, digestion, and more. All of these are chemical reactions, but yeah, we learned some of the important properties a chemical reactions should have. Okay. So, a chemical reaction is a process in which one or more substances, called reactants on the left side, are transformed into one or more different substances known as products. This occurs when chemical bonds are broken and new ones are formed, causing the atoms to rearrange into new molecular structures. This just means that what you have as reactants, their bonds break and form new ones to form different products. They form different products from the reactants. In a chemical reaction, the total mass of the reactants is equal to the total mass of the products. Total mass is equal to the total mass of products. That's because atoms are neither created nor destroyed. They are simply rearranged. Yeah, so in the video, they also counted the number of atoms. So to make sure that atoms are neither lost, destroyed, or created, we can count there is one carbon on the left, there is one carbon on the right, so that is equal. Even if the molecules are different, like CH4, this one is a CO2, they are two completely different gases by the carbon, but it is simply rearranged. Carbon dioxide does not magically appear. It's rearranged from CH4 and two oxygen gases on the reactants. Okay. Yeah, does this make sense for everyone? What a chemical reaction is? Um, yeah, if you do you have any questions about this?
Yes, you can continue.
Yeah, if you have any questions, yeah, feel free to ask. Um, yeah, and stop me anytime. Yeah, go ahead. Okay, I will start.
Okay. That's okay. Oh, English mama ho.
Oh, sorry, do you have a question or?
English
I
mama.
have a question. You can continue.
Ah,
Sorry, I cannot hear you.
If you don't have a question, you can continue.
Oh, okay, got it. Okay, then let's answer this question. This was from the past BEC question. I think it was from 2025. But calcium oxide and water reacts to form calcium hydroxide. Okay, so it asks you to find the formula of this product. So this is something that we haven't um, really gotten deep into, right? So it says to form calcium hydroxide um, from calcium oxide in water. We know calcium oxide, right? Calcium oxide is CaO. Mhm. That is calcium oxide. Um, to know the naming, basically for any type of ionic bonds, it has an "ide" at the end. But just to know that calcium oxide is CaO for now, and then it reacts with water. You know the formula of water? Yeah, it's just H2O, right? H2O. That's the formula for water. Okay, so this forms calcium hydroxide. And you just have to memorize what a hydroxide is. Hydroxide is OH. It usually is in the form of this ion, right? Hydroxide ion. Hydroxide usually has a -1 charge. Okay. Usually is an OH minus. Okay. So from calcium oxide in water, how does it form calcium hydroxide? Calcium ion has 2 plus charge. And you can note this. How do I know a calcium ion has 2 plus charge? Well, you can look at the periodic table, right? And calcium ion is on the second column of the periodic table. That means it'll form 2 plus. Hydroxide ion, we said, was OH minus. So calcium and hydroxide ion combining to form an ionic bond has a formula CaOH2 because you need 2 minuses and 2 positives to cancel out the charges. So we are basically saying +2 times what plus -1 times what is equal to 0. Mhm. For calcium, we just fit in 1 in the blank, 1. For hydroxide, we put in 2. So 2 minus 2 is equal to 0. That's why it forms CaOH2 as the final product. Okay, let me repeat this once again. Let me repeat this. So we know calcium oxide is CaO. Water is H2O. And it forms calcium hydroxide. What is calcium hydroxide? It is calcium ion plus hydroxide ion. Remember, calcium hydroxide equals calcium ion combined with hydroxide ion. And since calcium ion has 2 plus charge, 2 plus, and hydroxide ion has 1 minus charge, you need 2 hydroxide ions to balance the charges. So that is why calcium hydroxide is CaOH2, right? And always remember to check for balancing equations. This is the final step in checking the answer, because let's see the number of calcium on the left. How many calciums are in the reactant side? Does anyone know? How many calcium is on the reactant side of this chemical reaction? How many calciums? in just this reaction. In the reactant, there is only one calcium, right? Does everyone agree? Yeah, one calcium over here. One. Only one calcium. How about on the right? How many calciums are on the right?
One.
Yes, right? Yeah, one calcium on the right. How about oxygens on the left, on the reactants?
One oxygen.
Do you say one oxygen? Uh, there are
Yeah.
more than one. Yeah, there are more than one. How many do you think on the left side? So there are two, right? One over here,
Yeah.
one over here. Yeah, two oxygens on the left. What about on the right? How many oxygens? Yes, right. There are two oxygens because it is OH2, right? OH2. So there's two oxygens. And same with hydrogen, there is two hydrogen on the left, two hydrogen on the right. So we all checked out, right? Every atom on the left is equal to the number of every atom on the right. So this product holds. You don't need to add multiple things. So our final answer is B, the same calcium hydroxide formula that we got. Again, this was
Okay.
a more difficult question, but um, do you have any questions about this question, about this problem?
No.
Okay. If you have no questions, yeah, just feel free to
No.
ask me, yeah, whenever you want. Okay. Let's move on to ionic compounds then. Okay. So before, this problem was an example of an ionic compound. Forming an ionic compound. Okay. Ionic compound is formed when positive ions, cations, and negative ions, anions, attract each other due to opposite charges. Sodium. So, what is the charge of a sodium ion? Does anyone know? Yeah, what is the charge of a sodium ion? Sodium. Yeah, they,
Positive charge.
it discharges, yeah, one electron, so it is plus one, right? Sodium ion has a charge of plus one, right? What about a chloride ion? What charge does it have?
Negative charge.
Is a negative one. It's chloride? Yeah, chloride ion has negative one because you can see chloride here. You see chloride in this column. Always remember that The columns represent valence electron shells. The valence number of valence electrons. Right? So it needs one more electron to become stable. But chloride, sodium, which is over here in this column, needs one less electron to become stable. Right? So sodium loses, so it forms a +1. Chloride gains an electron, so it forms -1. But sodium ion and chloride ion can react to form NaCl, or sodium chloride. This is also known as table salt. Table salt. Let's look at another example. What is the charge on the calcium ion? What is the charge on the calcium ion?
I said it too. Positive 2.
But yeah, that's right. Yeah, great job. It's +2. Yeah, great.
Yeah.
+2. What about for oxygen?
-2.
Yeah, -2. Great job. So calcium ion and oxygen ion combine, right? Since +2 plus -2 is equal to 0, right? That's great. This is amazing because a compound should have no charges. So it forms CaO. That's the ionic compound it forms, which is called calcium oxide. CaO is called calcium oxide. Okay, the next one is kind of different. Let's look at magnesium chloride. What is the charge of magnesium ion? You know, it's +2, right? Yes, right. And for chloride is -1. Mhm. But the numbers are different, right? Magnesium ion is +2. Chloride ion is -1. How do we make the charges neutral, do you think, when combining these two ions? Yeah, how do we make the total charge 0? Yeah. Yeah, that's why we need two chloride ions, right? We need two chloride ions to combine. If we have two chloride ions, then this becomes the total charge of -2. Right? And then we have +2 for magnesium ion. This equals 0. Yeah. Yay, great job. So that's why we need two chloride ions. If it combines, this forms MgCl2. The final one is potassium iodide, or Ki. Ki just forms Ki because potassium has +1 ion, right? Potassium ion has a charge of +1. Iodine ion has a charge of -1. That's why it combines to form Ki. And at the bottom here are just examples of cations and examples of anions, which we already kind of know, right? So does everyone know how to get the number of charges in an ion? Does anyone know how to get them without them given? Does anyone know? How to get the number of charges in an ion? Yeah, we look at the columns. Always remember, we look at the column number. Sodium is in the first column, right? First column. That's why it has +1. Whatever is in the second column has +2. And then over here, on the second to the last column, this has -2 charged ions. These atoms have -1 charged ions. That is how you get the ion charges. You look at the columns. Okay. Okay. So let's just look at this question. The ion that causes hardness in water is, um, yeah, this popped up in a different type of question, but I'll just put it here.
B. B.
Yeah, B, right? So whatever causes hardness involves magnesium and calcium. Magnesium ion, yeah, has a +2 charge. That's why the answer is B. It has a +2 charge because magnesium is on the second column. Second column. That's why it has a +2 charge. Okay. Okay. Let's look at this question too. Which of the following chemical symbols can be used to remove permanent hardness in water?
B.
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 Yeah, you're saying B, right? Yeah,
B.
because yeah, that's right. Hardness in water is removed by sodium carbonate. How is sodium carbonate formed? Well, it's formed by, okay, let me rewrite this. It's formed by the number of sodium ions and the number of hydroxyl ions. So, sodium ion has a charge of +1, right? So it has a charge of +1. Sodium ion, +1. CO3 has a charge of -2. That's why you need two sodium, right, and one carboxyl ion in order to form Na2CO3. Right? Na2CO3. That's sodium carbonate, which is answer B. Right? Always remember that what removes permanent hard water is sodium carbonate. Remember sodium carbonate. Okay. This is something that you just need to memorize. If sodium carbonate removes hardness in water. And before, which one was it? Yeah. What can cause hardness in water is calcium and magnesium. Hmm. All right. Let's look at this question. And this part is about neutralization reaction. So what is neutralization reaction? Well, it is a chemical reaction between an acid and a base that forms salt and water. Any acid and any base can combine to form salt and water. That's how a neutralization reaction works. Okay, so this question was a theory question that involved a neutralization reaction. So let's read this together. A student who went to bed immediately after eating complained of stomach upset the next morning. The doctor prescribed a liver salt whose major composition is NaHCO3 as the medication. Liver salt is antacid and neutralize excess acidity, right? And using a balanced chemical equation, explain how the liver salt would relieve the student from this discomfort. Okay, so this is a neutralization reaction that would happen with stomach acid, since stomach acids cause stomach pain, right? Can cause stomach pain. Stomach acid is made up of HCl, hydrochloric acid. Remember that. And liver salt, remember, it says to neutralize the acidity. So liver salt is a base. Yeah. Liver salt is a base. Okay. Hydrochloric acid is an acid. Liver salt, which is NaHCO3, this is a base. This is a base. So acid plus a base forms salt and water, right? Salt and water. Acid and a base forms salt and water. Okay. The salt that forms here is NaCl. We get that from, the Na and the Cl, which are cations and anions that forms the salts. Just pretty simple. And then it forms water. And then it forms carbon dioxide as a byproduct. So this is the balanced chemical equation of a neutralization reaction. Remember, this example is called neutralization reaction because it involves an acid and a base. It's called, yeah, neutralization reaction. Okay, so
If you want to copy it,
oh, you want to copy it? Okay, okay.
yes.
Yeah, just let me know once you finish.
Yeah, we finished.
Wait. Okay, if everyone is finished, yeah, I will be moving
Yes.
on. Yeah, okay.
Yes.
All right. So let's get into some of the properties of acids and bases. So acids turn blue litmus paper red. That's their property. And bases turn red litmus paper into blue. Yeah. So acid, if you put a litmus paper in acid, the blue Yeah.
Can't you put it inside?
comes red.
Hey, it's already.
In a base, yeah, red litmus paper becomes blue. Okay. All right. So again, an acid, blue to red. In a base, red to blue. Okay. So this is called the testing with the litmus paper. And we're observing the color changes. So the litmus paper is a simple pH indicator that can change colors when dipped into acid or basic solutions. pH means the concentration of hydrogen ions. That tells you how acidic a certain solution is. Tells you the number of hydrogen ions.
Lemon.
All right. So in the acidic solution, the litmus paper turns red. And in acids, pH is less than 7. That's the number. In acids, pH is less than 7, and litmus paper turns red. So the blue litmus paper turns red in acids. If you dip a red litmus paper, it stays red in the acid. Examples of acids are lemon juice, vinegar, and hydrochloric acid. There are a lot of different kinds of acids. Yeah, but these are examples. Okay. I'll move on to bases. In basic or alkaline solutions, the pH is greater than 7, and the litmus paper turns blue. So the red litmus paper turns blue, and the blue litmus paper stays blue in bases. And examples of basic solutions are soap, baking soda, ammonia, and sodium hydroxide.
Yeah.
And finally, in the neutral solution, pH is exactly equal to 7. There are no changes. So both the red and the blue litmus paper do not change color in neutral solutions. Neutral solutions include pure water, and salt water, sugar water, things like that.
It's not. No, that doesn't change that. It doesn't change.
Okay, so I can continue, right? Yeah, so let's look at this theory.
Nitrogen.
Mhm.
Yeah.
Name the two elements that combine to form ammonia gas. Ammonia is NH3. So what are the two elements?
Nitrogen and hydrogen.
Yes, that's right. It's nitrogen and hydrogen. Yeah, that's simple. Let's look at number two. Okay. Write a balanced chemical equation for the formation of ammonia with nitrogen and hydrogen. Right. Okay, so let's start from the beginning. Right. So nitrogen and hydrogen exist as gases. Okay. So this is something that you just need to know. It exists as gases, so it forms an N2 plus H2 forms ammonia, NH3. But is this chemical equation balanced? Are there same number of atoms on the left and the right? What do you think?
Yes. Yes.
This one.
Yes.
Oh, do you want to maybe check for the numbers? Yeah. How many hydrogens are on the left side? There are two, right? There are two hydrogens on the left. How many hydrogens on the right side?
Three.
Three, right? So they're different, right? The numbers are different. So we need to
Yes.
balance the equation. Yeah, we need to balance the equation. So what you can do is that you can say that it produces two ammonia. This equation produces two ammonia. Then how many hydrogen atoms are on the right? How many?
Three.
Yeah, three, but there are two threes, right? We added two ammonia.
One. Two.
So there are two threes, right? So if there are two threes, then there are six in total, right? Because think of it like this. Yeah, think of it like this. So
Times two.
if there is NH3, with some other lonely electrons too, but if we have two NH3, it essentially means there are two NH3s. Right? There are two NH3s. Yeah, so there are one, two, three, four, five, six hydrogens in total. Okay. Now, we said that the number of hydrogens on the left is two, right?
Yes.
How do we make it six? Yeah.
Two times three.
Times three, right? Yeah, times three. So we need three hydrogen gases. We add three in front, right? Yeah, great job. Finally, what about nitrogen? Is nitrogen balanced? So there are two nitrogens on the left side, two nitrogens on the right side. Right?
Yes.
So yeah, this is balanced. So this is the final balanced equation.
NH3.
This is the final balanced equation. That's how you make a chemical reaction, right? By combining different molecules and atoms or ions. And then it forms a product, but at the end, you have to make sure that the numbers match. Okay. So does everyone understand how to solve this at this point?
Yes.
Yes. Okay, great job. Then I will move on to more examples. I'll move on to more examples. Okay, let's look at this example. The number required to make the following chemical equation balanced is what do you think? So what number should go in front of O?
Ah, 1/2. 1/2.
1/2? Yeah. Does everyone else think it's 1/2?
Question after you are sitting.
Yeah. Yeah, why might it be 1/2 in front of here? Well, there's one oxygen on the right. One oxygen. There are two oxygens on the left. Right? So you need to multiply 1/2, right? To make it 1 on the left side too. That's why what goes in front of O2 is 1/2. That's why, yeah, the answer is A. Okay, let's look at a few more examples. Which of the following chemical reactions or chemical equations is balanced? So, yeah, I'll give you some time to look through it. But yeah, I'll look through it carefully and you can tell me the answer.
B. Hello.
Say, yeah. Did you say B or D? Which one?
B.
D? Or which one?
B.
D? Are you saying D?
B.
Yes, if you said D, then yeah, that's correct. The answer is D because there are sodium, two sodium, two chlorine on the left, and this two NaCl. This means this in total, two NaCl. So there are two sodiums, two calciums, two chlorines, right? So that is why the answer is D. Why is it not B? Okay. On B, there's two potassium on the left, but there's only one potassium on the right. So this is not correct. Okay. So the answer is D. Yeah, this explains the reason why, right? And how it needs to be balanced, right? For A, of course, this was not correct, but this can be balanced by adding a 2 in front of HCl. If you add 2 in front of HCl, then the equation is balanced. 2 hydrogen left, 2 hydrogen right, 2 chlorine left, 2 chlorine right. For this to be equal, you need to add 2 on the left, right? And then 4 on the right. And then for C, you need to add 2 on the right to make 2 oxygen and 2 magnesium on the left. And then the final one was correct. Okay, let's move on to the final section, which is on science instruments. Let me see if there are more slides remaining.
Jeremy, continue.
Okay, for today, let's just look at a multiple science instruments and get to filtration. So yeah, let's just watch this video, this short one, and then we will continue.
Summer means road trips, epic plans, and making the most of every mile.
Glassware is one.
This has been in my leg.
So that video was about science instruments, and we got to see a lot of different types of science instruments as well. Yeah, and we saw and we will learn that there are 4 different methods of separating mixtures. One is filtration, one is by separating funnel, one is by magnetization, one is by distillation. Filtration separates solid from liquid or gas using a filter. Separating funnel separates 2 liquids, like oil and water, forming 2 separate layers. Magnetization uses magnetic attraction to separate mixtures. And distillation separates a liquid from another liquid based on boiling points. So these are 4 methods that we will study. But first of all, it is important to know what a mixture versus a pure substance is. What is the difference between pure substance and a mixture? Well, a matter can be both of them, but pure substance consists of pure elements and pure compounds. Pure elements consist of one type of atom, like oxygen, hydrogen, potassium, things like that. There are compounds like water, sodium chloride, and carbon dioxide. These are compounds, but they are pure compounds, meaning it is made up of that only one type of compound. But there are mixtures, right? There are two types of mixtures. This is important. There's homogeneous mixtures and there's heterogeneous mixture. Homogeneous mixture is when the mixture is thoroughly mixed or very well mixed together. These things include salt water, mouthwash, and alloys. And there can be heterogeneous mixtures, things like pizza, salad dressing, or landfill. And heterogeneous mixture cannot mix well together, right? And you can usually see different substances that are floating, right? That are mixed together. So again, homogeneous is mixed well, right? Can be mixed well, and each individual substance is not really visible. It's combined well. Heterogeneous mixture is not mixed well. Think about a pizza, right? In a pizza, there are multiple toppings, and those toppings don't mix with the pizza itself. That's why it is part, you can call it a heterogeneous mixture. Okay. Yeah, like I said, pure substance, this one on the left, pure substance on the left, they're made up of only one type of material. It cannot be separated into other substances by physical methods. So again, we had elements with only one type of atom, and compounds with two or more types of atoms. A mixture is made when two or more substances mix together, but they are not chemically combined. They can be separated using separating methods. But there are two main kinds of mixtures, like I said. There's homogeneous mixture, which is mixed well in this uniform composition. And there are heterogeneous mixture, where it is not evenly mixed. Salt water is salt plus water. That is a homogeneous mixture. And air is also a homogeneous mixture. It's a mixture of gases. Air that we breathe are mixed with oxygen, nitrogen, and carbon dioxide. Okay. Okay, let's end with one of the final questions and one more video on filtration. So let's answer this question here. A substance which is made up of the same kind of atoms is called what? Same kind of atom.
B.
You're saying B, right? B. An element? Yes, that is correct. Yeah, it is an element. Again, it's the same kind of atom. Number two. So which of the following substances is a compound? C. Yes, that is correct. The answer is C. Yeah. Water is H2O. It's not from the same substance, right? Compound is two or more elements. Two or more. Okay. So which of the following substances is a compound? Well, here, sucrose is actually, yeah, the compound. Sucrose is the compound because copper, Cu, is an element. Diamond is actually an element, but it's formed from carbon, right? Diamonds are formed from carbons, but they have a very specific formation. Sucrose is a compound made up of carbon, hydrogen, and oxygen. Sulfur is an element, right? S is an element. Okay. I think we will start the separation methods. Okay, we will start with the separation methods of mixtures in our next class. Because I think we have a few more slides remaining, but we will continue, from filtration methods next class. So today we talked up until, pure substance and mixtures. Next time we will learn how to separate the mixture. Yeah. We will learn how to separate the mixture into pure substances. Yeah, those are these four separation methods. Yeah, we will learn these next time. But do you have any questions for me today? Any other questions? Feel free to ask me. Yeah.
Thank you. We said I don't have any question again.
No questions? That's
Yeah.
fine. Okay. Yeah, that's fine. Then I think we will continue with more chemistry next week. Yeah. And if there are no questions, I will, see everyone next week then. Is that right?
Yeah, hello.
Yes, hello.
Always fair. So you're done for today, right? Yeah.
Yes, that's right.
Okay. And they said they don't have questions, so see you.
Yeah, they don't have any questions, so
Yeah.
yeah.
All right. You have a question, you can ask us. I'm just saying you can ask. Answer us.
Okay, so the students have classes next week, right?
Sure.
The normal.
All right.
Okay. Yeah. Then we will continue with the rest of the slideshow.
I think
And-
next week is vacation. Hello, Jamie.
Oh, next week. Yeah, okay.
Next week is vacation, so I think next term rather. Next
Okay.
week we'll be vacating on Thursday, so I think that'll be next term rather.
Oh, sorry, did you say vacation starts on Thursday?
Yeah,
Okay.
yeah, vacation starts next week. So
Okay.
let's schedule for next term. Yeah, then they will be in Form 3. Can you hear me?
Oh, so like when does the vacation end? Do you know?
Yes, please. Next week we are going on vacation.
So the week after that would work, right?
You there?
So the week after next week, would that work for the students?
That would be all through in vacation, but we go. Next week we are
2 weeks.
going on vacation. Yeah, and we will be resuming on September.
Oh, okay, okay, got it. Oh, I see.
So you talk to Prince then.
Okay, that makes sense. Um, do you want to have one more lesson before the vacation, or should we continue after in September?
Would you like to do that? I can set it up for you. Like to do that. And give me the day and the time and I'll do that for you. If only you want to.
Yes, okay. I think I can discuss and we might schedule for would next Wednesday work for you?
All right. Okay. Okay. That'll be fine.
Next Wednesday at the same
So
time.
next.
Okay.
All right. All right. So see you on next Wednesday. As
Okay, that sounds good. All right.
all right.
Yeah. Thanks everyone for listening. And yeah, I'll see everyone next week then, next Wednesday. Bye everyone. Yeah.
Yeah. And next day, Yamudu.
Wait, what did you say? Okay. All right. Yeah, bye everyone then. Bye everyone.